Good morning, all of you. Today we have to discuss this topic of the control of switch reluctance motor for electrical vehicle application. First of all, I want to justify why we have to should continue this topic of the control of switch reluctance motor. First of all, we have to go for the why switch reluctance motor. We have to choosing here. In a day, the electrical vehicle is the numerous of technology as well as the application is will be increased in concept of the application of motors. First of all, the motors in will be used in electrical motor. Most of the this DC motor as well as the induction motor. There's a high speed. High pole induction motor we also calls, and another motor so called as a BLDC motor and switch reluctance motor. The induction motors number of the uh, technology it will be invest or also because the number of the research are there available as well as the DC motor also same things, but nowadays BLDC motor and switch reluctance motor there is their technology as well as the research it will be increased, but we have to see in the application of this both motors, number of the application as well as the number of the merits and demerits are conflict from both sides. So today we have to discuss the why we should the switch reluctance motor is better experimental result as well as the better suitable for the electrical vehicle applications. Okay, now we have to starting. First of all, we have to going for the problem statements, introduction, and literature survey. What we have done in previous regarding the switch reluctance motor as well as the vehicle applications. After that, we have to discuss which applications and which advantages we have to buy from these surveys as well as the statement related to this statement. After that, we have to see in the vertical modeling method as well as the flux model method for this reluctance model. After for practical applications, power converter topology and power conversion theory also we see. How can we closed loop system work? Also we have to study about. And if you want, we have to control these motors as well as the torque for force as well as the speed. So which variables we have to available for this controlling? We also discuss about that, and after that we have to controlling from these variables. If you want, we have to go controlling this voltage as well as controlling this current, which method we have to use it for the controlling of the variable also we have to discuss. After that we have to discuss the some result we have to performing this by these methods, and comparison and review also be available, and future work or future need of this invention also be to discuss here. And last I will do putting the one conclusion remark on that presentations. Okay, now we have to start. First of all, why introduct switch reluctance motor? In a previous day, the electromagnetic engines are there. If you want, the 19th century, it will be a, first of all we have to steam engine. After that, the electromagnetic engine are there. So modern steppers motors as well as the called as a switch reluctance motor we have to use. But in a increasing of the era, we need to high current and high voltage type of the electromagnetic engine. So we have to not practically device like a MOSFETs, a DTO, and also we have to in short terms we have to call it shortage of the power electronics device. We go not go for this electromagnetic engine, and also we new invention by Ford called as a diesel engine. It will be cheaper than this electromagnetic engine, or after that we have to continue in diesel engines, and number of the petrol engines as well as the CNG engines it will be increased in 20 and 21 centuries. So and this electromagnetic engines application is gap downs, but in nowadays we have to in 1998 sorry 1964 from toward 1964 we have to also invent the power semiconductor device like a high current and high voltage type of the semiconductor device, IGBTs, MOSFETs, as well as the GTO and thyristors. So we have to reapplication these models from the previous electromagnetic engine, or we have to name the switch reluctance motors. Okay, what is the problem why using in electrical vehicle application? Otherwise, why we have to using this model to the electrical vehicle applications? Okay, so first of all, the most of the electrical vehicle application, most of the DC motors are used, as well as the some of the models, the Tesla and VW models, also the induction motor are used. But BLDC motor, we have to use it. The most probability is a BLDC motor has the permanent magnet. So permanent magnet is not suitable for the all countries, as well as we have to taking one example for India. Some magnet we have to import from this China, and we also know what is the relation between China and us is not good for that side. So BLDC motor, as well as the performance and evolutions of the magnet, is down by using this magnet. So it will be a one demerit for this BLDC motors. So instead of the BLDC motor, we have to using this switch reluctance motor. The almost the principle is same regarding the this permanent magnet. We have to create one imaginary magnet in a switch reluctance motor. So that is a big our advantages regarding this. Okay. First of all, we'll be taking the literature review in previous work. What is this work? Okay, first review we have to taking from the James Stephen papers, and as well as the, so there will be a conclude remark is the SRM is not suitable for this magnetic saturation under consideration. So there is a, we have to also talking about the what is the this flux modeling. So if are the we have to control this motor to determine the basically and meticulous analysis of this flux model, we have to do that for that. Okay, and second literature is all about the power electronics and closed loop control. Because of the every moment we need to one embedded system for the finding of the angle, or for rotor angle, or we have to call for the finding of rotor angle closed loop system, we have to need the digital signal processor DSP. So in previous era we don't have to DSP. DSP is introduced in 1971, quarter 1971, and almost most of power electronics is 1960 to 1964. There will be inventions. Okay. And third one is the, there is the sliding mode control. So sliding mode control, it will be a, if you want most of the practically method we have to invent is that already is the tap based control, but we need for the electrical vehicle applications there will be the sliding mode control. So we have to invent this sliding mode control for sharing with the flux function as well as the preferred vector diagrams. Okay, how we have to go for the, we have to almost two motors already we have to discuss. First is the induction motor is also be used in electrical vehicle application, as well as the second motor is the permanent magnet, or already we call as the BLDC motor, is also be used in electrical vehicle applications. So what is the difference and what type of the merits, demerits it will be an encounter from this switch reluctance motor we have to talking about. So first of all is the maturity of technology. So induction motor also we called in introduction part is high, permanent magnet is second numbers, and SRM is the last. So we need to mature technology increase. Okay, this is the number we have to out of 5. Okay. Power density is permanent magnet is high. Second number of this power density is SRM motor. High starting torque is permanent magnet as well as the SRM motor. It will be same. Cooling of the permanent magnet and SRM motor is same. But induction motor is the less amount of the score. Maximum speed SRM number is advantages. Maximum speed range SRM is advantages. High peak efficiency SRM is the second counterbalancing of this scoring, and range of the high speed, it will be a SRM is also be high. Loss of the control due to the back EMF. Because of the every power electronic switch, we have to need for this maintain the potential difference between anode and cathode. Also we called the collector of emitter. So every movement of this motor, it will be a produce of the back EMF. But this back EMF is not allowed to switch on this particular power electronics device. So we have to control this back EMF for this closed loop control of this motors as well as the power electronics device. In also called the VFD drive as well as the DC converter, whatever we have to use. But here the was switch reluctance motor, it will be not effect this EMF, back EMF effect. So we have to directly control or easily control that power electronics device for this uh, control method, as well as the temperature capacity is high. Noise and vibration is the biggest demerits of this motor. But nowadays we have to increase the technology, also we have to reduce. There is a one demerit is a noise and vibration is the number. Second number is not a bigger amount of this issue, but there's a still issue. Okay. Torque ripple also be permanent magnet and switch reluctance, same principle. So both are the same. Robust fault tolerance control. So what is the fault tolerance control? So what is the fault tolerance control? The fault tolerance control, it means if you want our induction motor is not working too fast. Okay. Or permanent magnet is not work in losing of the one phase or whatever we have to call. So the one axis. But here the switch reluctance motor is work whenever the any phase of the switch reluctance motor or the any pole of the switch reluctance motor is held, it will be a work as the robustness as per the previous condition. Okay. After sensorless control capacity, or it will be a possible by using the observer based control theory in switch reluctance motor. And the VA demand of this switching reluctance is a higher amount of the score. So total score, the SRM is achieved is a 42 as well compared to the permanent magnets as well as the induction motor. So induction motor is achieved the less number of this score is 29. Okay. So now we have two advantages. So first is the performance. We have also derived from this previous table. Small size unit we need because of the low wear demand. We have to need low cost. So we don't use any specific material other than this iron ore. We need of this ore. Cost of this motor will increase. High speed acceleration capacity will also be increased. Cooling, we have to use this cooling called as a cooling technology. We have to increase. So this is one advantage. Second things is the rugged constructions. So what is the ruggedness? We have to also be discussed about in fault tolerance control. Control. So fault tolerance control, it will be capable for this. So we have to and device test the ruggedness. There's the one mathematical model. So whenever this energize the core by this iron part, this iron part, it's a movement. So now in previous, okay, these are some iron parts called as A or A dash, B or B dash. We have to work in about this. So every movement of this iron parts energized, it will be work as a magnet, and they will be energized from this second part of this motor called as a rotor. It will be rotated from one direction to a second direction. Also we call so one movement to the another movement. Okay. But this is the method model of this flux linkage with respect to the current. Okay, so there is the one part of this two or 0 to B, A or 0. There is a one part. There is only this model or only this region. The motor work as the linearly. This is the biggest disadvantages for this motor. So we need to control the motor between this region. This is the modeling region. Okay. For now, we have to talk in or go for this vehicle modeling. Whenever we have, this is called also passive modeling. Okay. Or also assume this is the two-wheel vehicle. This is the base of the this same. Although we have to here, one is the font horizontal distance between C and this is C and G point is will be a front axis to the rear axis, it will be a same. Or we have to quote the frontal area of this vehicle. This is the frontal area of this vehicle. It will be also be given. Or also we have to define there is the decline angle as well as the longitude value velocity or radius of the wheel. We also be discussed from here, and drag coefficients or we have to also be uh, and here we have poles calculated, and for this mass of this vehicle also we have calculated. So what is the velocity v? V is the accelerated by this motor. So m dvx by dt, the force is considered from this side. But what is the mg or this decline angle? So aerodynamic drag force, it will be fd is equal to minus 1 upon cd rho a vx square sigma del vx. Okay, so we have to directly this force according this that is the acceleration by driving via the force, we have to also be calculated from this equation. Okay, there is the one principle or operating of this motor. It will be here we have to develop. So first of all, this is the aligned position, second is the unaligned, and third one is the misaligned. Whenever the pole of the rotor and stator is the one direction as well as the one axis, we call this a aligned position. Second one is the pole of this motor, rotor as well as the stator, it will be a same direction, but there is the not in reference, so we call this the unaligned position. And third one is the misaligned position. So pole of the rotor as well as the stator is not in one only one direction, we call this a uh, misaligned position. Okay, whatever we have to also be talking about in previous, there is a modeling, linear flux modeling. So modeling in the motor, it will be a based on the sum of the choice. There is the model of the linear flux region. We have to take in about the four effect in our accounts. First is the no saturation effect. Second is the mutual induction are ideally zero. Because of the number of the pole in stator, it will be increase the mutual induction. It will be not a symmetrical to this rotor. The magnetic field distributions is also be sinusoidal. Because of the we have to calculate the speed as well as the number of the pole required in stator side. The silently shape stator we also be need because of the fundamental frequencies present in induction per phase. If what the fundamental frequency is not present in there, so our power converter theory, there's a back EMF effect, back EMF effect are there, and not run those our power electronics components in properly, or malfunction effect are there. Now we have to talk in about the power converter topology or power converter theory. Here we have to see in the one leg of this power converter, there is a Q1 and QT. Q2 is the control device and D1 in D2 is the uncontrolled device. Why we have to use this D1 and D2? The D1 in D2 is the control of this back EMS. Those are produced by the SRA, or it will be controlled by the D1 and D2. Or the Q1 and Q2, it will be a control for this particular phase. Here this black is the phase per winding, so we have to control the why we need this analyze for particular phase. Okay, after we have to go for the closed loop system. Why we need to this closed loop system, and how can we implement this closed loop system? For the implement of this closed loop system, first we need from the back side we have to talking about. If you want to, we have to indirectly control this speed. We have to first of all taking about the one reference speed, it's called as a omega star, omega hashtag or omega star, whatever we called. And second is this the actual speed. After we have to conclude the speed controller as well as the fuzzy logic controller, PI controller, neural network, whatever we have to. And this signal is the commutations controller, which phase we have to new. And after this commutator's control, we also we need of the current controller. Because of this current control is energized by the using the current. So we need this current for the innermost current loop is implemented to buy a current tracker, which consists of the current controller and power converter is the starter winding for the SRM and current sensing device for the feedback of this controller, and position and sensor are also be used for the commutations controller. Because of the, if you want, we have to 0 degree of this motor and we need to analyze from that, or sometimes it may be a possible to this motor is also in 90 degree or whatever, 30 degree or whatever in degree. Okay. First of all, what is the problem in starting of this motor? Is the starting of this motor is the choosing of the excitation current for the according to source of the winding capacity. If you want, we have to know the choosing or choose of this current. We have to also be burnout of this winding is possible, but we have to exciting the phase B. This is a reference phase A. We have to choose this current. It will be not excited. We go for the calculate the current value in once. After that, we have to go. If you are the excitation, we have to go for the next side and excite the next head and rotor position according to rotor positions. Or still, they will be. We have to calculate the recurrent, and still they will be not excited. We have to determine the what is the flux linkage model, and it will be a winding or resistance of winding for connection of this windings. Okay. Now we have to go for the which control variables it will be a control to this SRM drive. The SRM drive is enabled by the voltage source as well as the current source. So two variable we have to have. First is the current source and second one is the voltage source. Okay. Third is the position of this rotor. Okay. And fourth one is the amplitude of current as well as the conductions angle. We also be use this type of the variable for this control. And now first we go for the hysteresis current control. This the hysteresis current control is using for the current control strategy. This the current control strategy is the switching when the voltage are there and we have to bend with this hysteresis current. It will be a reference of this band of this current. It will be a directly work as this particular problems. Okay. Second is the pulse width modulation control. So PWM is somewhat less responsive to change in the phase current than the hysteresis current control. But it is the very well suitable for the fixed speed of this in the industrial variable speed drives. Whenever we need to the industrial speed drive, like as the VFD as well as the DC-DC converter based speed drive control, we dynamic load as well as the static load are the changing in the number of this times, as well as also we called is the transient stability is the not extreme our point whenever we have to at the time we have to use of this pulse width modulations control. Okay, and next is the phase angle control strategy. Also we have to one example, or also we have to read a previous technology of survey. So all of the motors have two variables. For most probably these two variables, one is the voltage and second one is the current for the controlling of this motor. But this motor, one of the biggest advantages is the angle control strategy. This is the third variable for the controlling of this motor. Okay, having the define of this some angle in terms of the phase angle and effect of this control, it will be a parameter or also be called the motor performance as well as the motor efficiency or motor uh, a standardization is also be degraded. If we want, we have to change in this uh, phase angle. The speed of this motor is not in a rated. It may be a less or uh, high. Okay. So several phase angle control strategy are possible, which varying the degree of the expensive and complexity. But for this controlling of this phase angle selection, first of all, what is the difficulty in phase angle selection? For the directly proportional to the applied voltage is the inversely proportional to the phase inductions. So we have to maximize the positive torque in necessary applied to the phase quickly to before the induction slice. So also because the induction is the non-zero at the all positions, but because of the all the phase angle, it behaves on the positions of this phase. So turn on the any of the angle by determining the operating mode of this motor for the following of the inductance region for the generating braking as well as the generating of this power by using the regenerative braking. Okay. Here you have to see in the simulation result by this open loop startups. Here you can see the time frame by we have to first of all taking this reference current is the 50 ampere. This is a 50 ampere is a reference current, and after this reference current speed it will be increased, but it not a definable speed whenever we have to using this open loop second things we have to reference current is 100 ampere. That's the one of the starting current reference current it will be achieved. After that there will be a stable at something in 70 ampere because of the power density of this motor. It will be they will be going for this for around the 4,000 rpm for this, but it's not always stable from this 4,000. Now we have to from this closed loop system. First closed loop system we have to taking the reference of the 1000 rpm. It will be taking the time of this uh, settling of this 1000. Second we have to define just the reference current in 100 ampere. Yes, if we are taking of the time for settling 1000 rpm, it will be less. So here there is a comparison. So DC link RMS current for this 50 ampere reference current and 100. So 50 ampere reference current, 58 is the DC link RMS current, or the 1000 sorry 100 ampere. There's a 108 ampere is the RMS current for this DC link, and steady state value of the speed is the 1960 and 4010 rpm. So torque it will be almost same because of the we have to take given this torque in 5 Newton meter for this. And here the settling time of this speed, it will be 1.25 second in 50 ampere and 0.25 second in 100 ampere. So current is the same, and almost get some error in 0.0 something. There will be a in speed because of the whenever we have to steady state speed in 50 ampere reference current of this 50 ampere is 999.2, and is the 100 ampere 1 ampere the reference steady state reference speed is the 100.4. Okay, now we have to see the word whenever we have to the changing angle. This is called as a advanced angle changing technology. Whenever the we have to change this advanced angle, there's a zero angle. Whenever we have to first taking the angle of this zero, there's a speed response by the we have to taking the advanced angle in zero, and the one of the we have to taking the what is the difference between the source current by taking of this motor is also be different from this zero. We have to hear the step by the 5 difference it also be possible. First of all, we have to taking of the 0, 5, 10, or 15. We have to taking this one optimal uh, angle between them. If you want, we have to taking the 5. There's a less response. First of all, we have to 0. There's a ref response. Increase this angle by 5 degree. Some response it will be increased. After that, we have to increase. That the response is also be increased. But after we have to increase this angle by 50 degree, response it will be a decrease. And here the settling current it also be a reflected whenever we have to the speed it will be a reference. Okay. And after that we have to use this fuzzy logic controller for this SRM model, because of the we have to facing this issue in simulations result, because whenever we have to using this advanced angle control strategy, advanced angle is 0, the response is less, advanced angle is 5 is increased, advanced angle is 10 is also be increased, but advanced angle we have to increase in 15. There will be not determined which advanced angle we have to suitable for this operation. So we have to also be need for this optimal angle selection. For this we have to implement this fuzzy logic controller, and this fuzzy logic controller and conclusive remark we have to seen in next lecture. So I hope you all are the uh, good knowledge of this switch reluctance model. So in this next lecture, we have to study the whatever we have to choose that. Thank you so much.